This is Mr. Beck Does Your Homework. This is AP Physics, Homework 8.3, questions 11 and 12. Question 11 says, a gas is compressed at a constant pressure of 0.85 atmospheres from 8.59 liters to 5.43 liters. In the process, 309 joules of energy leaves the gas by heat. What is the work done on the gas? Well, I know that my work is negative P delta V. In this case, I am compressing the gas. I am doing some work on the gas. I'm taking that gas that starts off in this container and I'm pushing this way and moving the piston from here down to there. I'm going to make the container smaller. So my delta V is going to be negative. Well, that negative, a positive pressure, a negative, and a negative delta V, I will be doing positive work. So as I compress it, I'm doing positive work, and that's what I'm asking for done on the gas. So that's going to be positive number because I'm doing positive work. So now I need P and I need delta V. On my P is 0.85 atmospheres. That's not going to give me joules. Instead, I'm going to need pascals. So I have to take that and multiply it by 101,300 because that's how many pascals are in 1 atmosphere. So multiply those together and I've got my pressure. My change in volume, let's see, my delta V is going to be my final volume minus my initial volume. It's going to be 5.43 minus 8.59. So that's going to give me some negative number of liters, right? Because that's a bigger number minus a smaller number minus a bigger number. But that liters isn't what I want because that's not going to give me joules. So to get liters, I need this in cubic meters. So when I get this number, take that number and divide it by 1,000, and that's going to give you meters cubed. But your delta V is negative, but again, delta V is negative, that negative is there. So if you just take the absolute value of this, you're going to be in good shape. So you need P delta V. This times this is going to be your work done. So your work is going to be negative P delta V. Your delta V is negative, so you wind up with a work done. Okay, and that's going to be in joules. What is the change in its internal energy? Well, here we're going to use that other equation that we've been talking about, that your change in your internal energy is going to be how much heat was added plus how much work was done on the gas. So this becomes a very simple part of the equation. So it says 309 joules of energy leaves the gas. So if it leaves the gas, then my delta U is going to be, my Q is 309 joules of energy leaves, so that's negative 309. That's how much energy is leaving. So I've got some energy coming out of there. So I've got some Q leaving there while I'm doing work on the gas. So I'm trying to put energy in by doing work, but I'm losing some Q. So there's my negative 309 plus however much work was done over here. Okay? So my change in energy is how much work I do, that adds, and then energy is leaving, so that subtracts. So plus that minus that is going to give me my delta U, which is my change in internal energy in joules.